Java is developed in the OpenJDK, and that's a community and a project structure. And whenever new features are introduced into Java, this usually doesn't happen on a whim, or actually it never happens just on a whim. There's like a process involved that tries to determine what shortcomings there are and then proposes solutions, goes through a lot of prototyping, all of that. And this process is covered by projects. So there are a bunch of them, a lot more than these 4, but these are the 4 most interesting ones at the moment. So that's why I picked these 4. So we're going to go through 4 different projects, each of them covering a lot of ground, each of them doing very extensive and very interesting work. And Brian Getz, who works on, among others, Project Valhalla, was once told that this is like 6 PhD theses in his project. So by doing some quick math, we have about 4 times 6, that's 24 PhD theses ahead of us in about 50 minutes. So as also Brian Getz once said, I prepared too much, so I'm going to talk too fast. So this is not here to give you like a tutorial on all of these features. I'm just going to give you an impression of where Java is going. And if you have any questions, we might not have time to ask them right now during the talk, but find me around the conference. I'll be there all day, including later at the after party. I love to talk about all of this. So please don't be shy. Just ask me when you have any questions. OK, so the slides are already online as well, so you can check those out if you want to. Let's start with Project Amber. So what is Project Amber about? The idea is here, each of these projects has like a mission statement. And Amber's mission statement is smaller productivity-oriented Java language features. There are a bunch of links to the project, to the wiki, to the mailing lists, and all of that. So what's the motivation behind Amber? So Java has, as we all know, sometimes a little bit of a shortcoming that sometimes you cannot express exactly what you want to do, what you want to say in code, and that's when you start to have to write boilerplate and have to, write more cumbersome code that you really want to. And the idea behind Project Amber is that it is a solution to this set of problems, or rather more like a solution factory. It's going to look for the next place where Java needs some improvement, and will try to come up with a solution, with a proposal. And it already did a bunch of things. So it already had, like from bottom to top, that's the chronological order, local variable type inference, switch expressions, text blocks, type patterns, record, switch, seal classes. All of that already happened in various Java versions. Whenever you see a circled number like this, that's the Java version the feature was finalized in. You can group these together. Most of these are concerned with pattern matching. Like records and seal types and type pattern matching, all of those like go together to implement this one larger concept. They all have value on their own. Specifically, records are great on their own, but they play together to implement pattern matching. And I'm not going to talk about that because already a bunch of people do that, so that's already boring a bit. I also made a video on that about data-oriented programming, which is a term that Brian Getz not so much coined, but wants to apply to Java specifically. So if you're interested, that's you can see the link in the slides, but you can also go to the Java YouTube channel and you can find it there. So that's more about data-oriented programming. I want to talk about something else from Project Amber that they're working on at the moment. I want to talk to you about string composition. So the idea here is that I'm using, that I want to create an SQL statement as a string, and the way I do that is I have to somehow connect these different strings, right? So there's the select star from part, then there's the property that I want to embed. And I can use 2 different ways. One of them is just using a plus, and the other one is I can use a format string. It's pretty great. It comes with a free SQL injection. It's all pretty nifty. Okay, so why is it so complicated? Why can't we do this simpler and faster? Other languages allow us to do something like this. So in this case, I have a variable embedded, so the syntax highlighter, of course, doesn't know this yet, but where it says property and value, this is where the variables of the same name should have been embedded. And that's great. Now we can get the SQL injection much faster. So let's talk about SQL injection in general. Interpolation, string interpolation, not SQL injection. Let's talk about string interpolation in general. So the injections are not the only concern here. In general, when we want to put strings together, we don't usually do this for an audience of humans. We most often create structured text that we want to send to a web browser, want to send that to a database, to another service. So most often we have structured text that follows specific rules that must be verified. And so not only SQL injections are an issue here, you also don't want to send back illegal JSON or a faulty HTML string, all of that. And this is where string templating enters the picture. There's a JEP for that since very recently. I think I actually typoed the numbers. I think it's 430. That might be a typo. I think it's 430. Let me see. Yeah. So that's JEP 430, not 403. My bad. Right. And so the idea behind is that we introduce not one new thing, namely string composition, but 2 new things. String template and then a template processor. So let's have a look. I'm using the text blocks here with the 3 quotation marks, but that's just because it's more readable then. It doesn't make a difference. So what I'm doing here is I have the text block, and in that text block I use the backslash curly brace to introduce an embedded variable. I could also use not just variables, but probably we could also be able to use expressions there. And so that's the one part, embedding variables or expressions inside a string, and that turns it into a string template. And the second step is that we have a processor that turns the string template into a string. There's an asterisk there. We're going to see later what we're going to come back to that in a minute. Okay, so let's give you an example. So this is a payment slip, and this payment slip consists of references variables called price, quantity, and all of those, the tax is in there, and those variables are referenced within that string composition, and then I use the specific policy called str, which is just concatenating strings. It's doing the stupid and simple thing of just embedding the variables and nothing else. And what you get is then the string down there, which looks kind of okay, like quantity 3 and the unit price is there as well, but then you have a total that's like a fraction of a cent, and that's always hard to pay, specifically if you're still using coins like I do. So yeah, that's not great. So the idea would be that then there could be different templating processors. So this is a different template processor that behaves differently. It takes as input a slightly different string, because this string not only references a variable like quantity, but it also embeds these like formatting strings that you know from string.format. If you can't read those, don't worry, I can't either. I always have to Google how they work. But the result is that now we get a formatted string that has rounding, for example, in the very bottom. So now we can pay with like full cents, which, as I say, is helpful. So what you see now is this string template, 2 slightly different templates that were piped through 2 very different processors to lead to then different results. Okay, now I want to come back to that asterisk. Why are we even talking about strings? Because here's the thing, as I said earlier, we're often talking to other systems. And if I send something over the wire, for example, then that JSON might actually be transported as a string. But most often, or maybe not most, but very often, I want to send this to another system, or sorry, I want to use it internally within the same system, and then I want to actually turn this into something. So I don't want to have just the string and then the values, put them together through a string, but I often want to parse that. Then again, so that means I dumb it down basically to the very simplest text format, which is a string, and then I have to start parsing it, and I have to verify it and everything. And the question is, why the detour there? Why can't I just go from string and values to something smarter? And the answer is, we can. So this is the interface for the template processor. And as you can see, it takes one of these templated strings as an input. That's a string with these embedded expressions and variables. But the result is not a string necessarily. It's of any type. So a template processor can create objects of any type. And that's amazing, because what that, if the proposal is implemented as it is proposed right now, what that would lead to is something like this, where we have a policy, SQL, that can come from some external library, for example, doesn't even have to be within the JDK, that implements not only the string concatenation part, but also the parsing part and the verification, the validation. Is this an actual SQL statement that is valid? It can do all of the escaping that is necessary to make sure there is no injection. So this SQL templating processor can embed all the domain rules from the SQL domain, and then we can have another one that does the same for JSON, and that one would return a JSON object. So it doesn't have to, but it could. So these different processors will all take templated strings as input, but as output they can create a domain-specific object that we can then use further. So this way, for example, would be sure that this is a valid SQL statement, and at the same time have only done the validation and parsing once, and then can pass it on. So that makes it safer and faster. Okay, but this is not the only thing that Ember is doing. As I mentioned earlier, template string has a JEP now. This time it's correct, 430. So that means in this long process from somebody having an idea to a white paper or mailing this discussion to maybe then there's a JEP draft, and then it turns into a JEP, which is short for JDK Enhancement Proposal. That's the instrument that these projects use to actually change the Java language. And even then it might be a preview feature. Actually in the future, all of them will be preview features first. And then after 2, 3, 4, 5, whatever many versions is needed to finalize it, then it will be finalized. So that's like a long process for a feature to go through, and having a JEP is somewhere in the middle of that, maybe a little bit further towards the end. But I'm telling you all of this because that means it's by no means final. What I just showed you is a proposal. Like this could not happen at all. It could change a lot. So with most of the things that I show you in this talk, this is not necessarily how it's going to turn out in the future. Okay, so templating strings are one thing that Amber is investigating. Then we have pattern matching, which is going to be finalized hopefully in JDK 21, because in 20 it's still in preview. I was hoping for it to be finalized then already. There's going to be more patterns in the future. We already have a JEP for one more pattern. Concise method bodies is an interesting idea where I have a link here. And then the whole serialization engine is somewhat suboptimal, and so there's the goal to maybe find a way to tackle that, but that's still in the white paper phase, so very early. So Amber really has its work cut out for it, and there's going to be a lot of changes coming from there in the future. So the goal overall is to make Java more expressive, to reduce the amount of code that we write without making it harder to read, and to make us as developers more productive overall. Now, usually when I present these things, people ask, like, when is that going to happen? And the official answer is when it's ready. But that's also a very boring answer. Now, I could ask Brian when it's ready, but he will tell me either the official answer when it's ready, or maybe if he knows more, he could tell me some of his thoughts that then I couldn't share with you, so that would be boring. So don't even ask. Instead, what I do is I guess on my own. So these are my personal guesses. You cannot sue Oracle for this. This might be totally wrong. But I just want to give you some ideas. Yeah, so JDK 19 has the deconstruction pattern as a preview. And then next year, we're hopefully going to see the pattern matching. And I really hope that, finalized, and I really hope that the template strings will also show up next year. And then we'll probably get more patterns in the future. There are more ideas for those. But Amber has been really good with coming up with surprises in the short term. So we might see stuff that's not even on my timeline here. If you're interested to dive deeper, there's a bunch of links here to some videos and some articles that have been written, so I can only recommend that. With that, let's get to the next project. Short breath. Panama. Panama is about interconnecting the JVM with the native code. The idea is that native code is like maybe the Pacific, and the JVM code is the Atlantic, and just like the Panama Canal connects the two, Project Panama is trying to connect the two. Once again, lots of links. Let's go into it. So Panama falls apart into 3 projects: Vector API and the foreign memory and the foreign function API. But the last 2 are strongly connected, so we're going to cover them as a whole. But before we get there, I want to talk to you about Vector API and vectorization. So what I have here is a very simple mathematical operation that happens on a bunch of values. So what I'm doing is I'm getting 2 input numbers, and I want to square them and add them up, and then take the negative and then store the result. But I'm not just going to do that with one pair of A, B for one result. I'm going to do that with a whole array of A's and a whole array of B's, and then create a whole array of C's. So the simple way to implement that is what I've shown you here. It's just a for loop, right? You go from 0 to the length of the arrays. They must all have equal length, of course, and then just do the math, right? That's very straightforward. Okay, so that's code that you probably write like that, and that's fine and dandy. But modern CPUs can do much, much better than that. So this laptop, for example, has 512-bit long multi-word registers. That means you can have 512 bits, that would be what, like 16 floats, I think, in one register, and 16 floats in another, and then you could add them to 16 results, and that takes about as much time as a single addition. So that's a 16x speed up. That kind of stuff is an amazing performance boost. That's what MMX, I think, on Intel was about. It's great for all kind of media, for image decoding and encoding. It's good for machine learning, for everything that is math heavy. This is amazing. And that's why the just-in-time compiler knows about it. It really tries to hit these kinds of operations. But the issue with that is that it falls apart quickly. It's not easy for the just-in-time compiler to be sure that a transformation it applies is actually always producing correct results, because the just-in-time compiler can't do something that is probably correct. It really has to be correct. And that means why it's nice when you get this performance boost for free, but you cannot really rely on it. So the idea here is to introduce a new API that allows us to write code that reliably compiles to these multi-word registers, and then the SIMD instructions, what they're called. I didn't mention that because you give a similar instruction like add or multiply to multiple data points, so like multiple pairs of numbers, for example. Okay, so let's have a look at the Vector API. Compared to the very simple operation I showed you earlier, this is much more complex. But if you look at what the requirements for this API is, it's actually doing quite fine. And if you get used to it a bit, it's readable. I don't want to go through all the details. I'm not going to go over what the species is exactly and how the loop works. I think I want to focus on these lines, VA, VB, and VC. So VA is vector A, which means pull a bunch of numbers from the A vector, A array. Vector B is pull a bunch of numbers from the B array. And then vector C is do the computation. And this is great, like big integer style math. Everybody loves that, writing methods instead of operators. But that's where we are at right now. So that opens the door to maybe we need operator overloading in the future. That's like way down the line, but it is a consideration because of this. And then we write the result into array C. And the point is, at runtime, we will know how long, like on a specific machine like this one, we will know how long the multi-word registers are, so we can pull just the right numbers of arrays or a right number of numbers into the vector and all of that. So given that, it's a comparatively clear and concise API, even though it's a little bit more cumbersome than just writing out the math. But the important part is it's platform agnostic, so whatever operating system, whatever hardware architecture you're targeting, or the project rather is running on, you don't have to target it, this will compile down to optimal machine code. And even if the processor you're using doesn't have this, it will just compile to the same machine code that is essentially the loop. So you will see no performance degradation with this. It can only become better. And that is huge for everybody who uses stuff like, as I said, image processing, machine learning, anything that is very math intensive. We're probably not going to write this code ourselves. More likely we're using libraries already, and those libraries will hopefully adopt this and will give us this reliable performance boost. Let's talk a bit about the foreign APIs, but I want to cut this short because this is not only is this a 50-minute instead of a 60-minute talk, so I want to have some time left over later, but also it's about native code, which is not really my forte. Like I once tried to learn C and C++, but I realized it's just going to make my life so much more complicated, and I decided not to. So yeah. Right, okay, so what is this about? We have two aspects here. We have the idea to store memory off heap, and we want to call native code, like a C library. And these are related because if you put stuff on the heap and then call a C library and point into the heap, and at some point the Java garbage collector decides, you know what, let's just collect some garbage and move everything around, then the native code points wherever, and it's not going to go well from there. So the idea is that you have to put data off heap and then call a native function to operate on that, and then you can import the results back into Java. And both of those situations, putting stuff off heap, which has other applications beside native code, but that's also an important one, and then also running native code has different shortcomings that are summarized here on the list. Everybody who's using JNI is not super happy with that. Everybody who's storing stuff off heap either has to use unsafe, which is unsafe, or use byte buffer, which is very limited. And this is where the new APIs come in. The idea here is that the foreign memory and foreign function API introduce new programming concepts, or rather new types to tackle these problems from a fresh angle and with a better understanding of what's going on here. And specifically, the foreign memory API does not try to map everything onto a single byte buffer class, but gives you more choice and more interaction with what you're doing. So for example, one important thing is that you have the memory session, for example, where you can manage how to deallocate memory, which is a problem with the byte buffer. So this overall gives you more control of what's going on with the foreign memory. And the foreign function API similarly introduces a few more concepts. It uses method handles, which is a comparatively low-level programming tool that Java introduced, I think, in 8 or 7, I think. And for you to not have to generate this very low-level, or write this very low-level code yourself, JExtract is a tool that will take in, let's say, a C library and will spit out a Java file that uses the method handles. It's very low-level, and it's very one-to-one correspondence between the APIs. And then you're going to write your API on top of that Java file, which is pretty great, because the next time around when the C library updates, you just run JExtract again. If the C library didn't change its API, you get the same file, that's great. But if it did change its API, the Java file that you generate will look slightly different. You will get compile errors probably from your API that's calling that, and then you can follow up with that. So overall, it reduces the number of moving parts and makes it easier specifically to update to newer versions of a C library. This time, the timeline on these things is very official. This is what's going on right now. So JDK 19 contains both of these APIs as a preview. There have been incubating modules in the past. Now both of these foreign APIs come together as a single preview, and they will preview again next year, so for Java 20, and then we'll see when they get finalized. Now the vector API is already pretty mature. It would be nice to finalize it, but it's leaning on Project Valhalla, or it's hoping rather for Project Valhalla to bring a few things that can make the vector API more usable and faster. And it would be a shame to now finalize the vector API and then realize in 2, 5, whatever years when Valhalla is done, to be like, oh, dang it, now we don't have like the optimal API. So that's why vector API is probably going to stay incubating for a while longer. But it's already doing pretty great. So if you really, really rely on that, I don't know, look into it definitely. Okay, so there are deeper dives again on the vector API. There's the great article by Gunnar Morling wrote FizzBuzz SIMD style. It's really great because FizzBuzz is not a problem that is very amenable to being used in this with the vector API, but he works through it, and I learned a lot about the vector API from that. And then there's a bunch of articles and videos on the on the foreign function and memory APIs. Okay, with all of that said, let's go into Project Valhalla. It has the murkiest mission statement of all: advanced Java VM and language feature candidates. It's like, okay, so anything that's advanced goes in there? It's not that vague, actually. I think that the specific mission is much more precise. The idea here is that Java's type system is split, and that should be mended. So what do I mean when I say it's split? We have primitives, and we have classes. And on pretty much anything that you can use to classify types, these are on polar differences, right? So for example, primitives do not have an identity, but classes do have an identity. I'm going to explain in a second what I mean by that exactly. And then the same is true with references. Classes have them, primitives don't. That would all be, okay-ish if we could create both, but we can't. We can only create classes. So whatever we create at the moment always has identity, always has references, which has considerable downsides. So let's talk about identity. What's up with that? So identity means that if you have a new integer 5 and another new integer 5, that these two integers are somehow different. Both are 5, but they are both also not identical, right? If you had used the two equal signs to compare them, you get a false. If I ask you what would happen if with an int 5 and another int 5, you'd be like, how is that even another int 5? Aren't two int 5s the same thing? And that's exactly what identity is about. Two int 5s are the same. There's no way to distinguish them because they do not have identity. Two integer 5s, they are distinguishable because they do have identity. And identity comes with extra memory for the header. It's the thing that enables mutability. So if you want to mutate something, you need to know what it is so you can change it. So it still is the same identity, but with a different username, for example. It also allows locking and synchronization, all of that. And that's great in general. We need those things, but we don't need those things on all types that we create. And it's similar with references. So references also come with an overhead. In this case, in Java, most things except for primitives, everything, in fact, is a reference. So when you call a method with a string, what you pass on is just a reference, basically. And then, the actual char array is somewhere in memory that needs to be hunted down. And that indirection can be a performance issue. And it can also be specifically a caching issue, because if you have an array of strings, you don't actually have an array of characters, but you have an array of pointers that point all over the memory, and so you can get a lot of cache misses there. It also allows nullability, which again is a good thing to have in general, probably. I'm not convinced. I really don't like null. But definitely something that we want to get rid of in certain situations. And it's also protected from tearing, but I'm not going to go into that today in the interest of time. Once again, not all custom types need that. And what Valhalla's goal is, Valhalla wants to give us tools that allows us to get rid of identity and references when we don't need those. So specifically, Valhalla wants to introduce value types. Value types say, I'm mostly like a class, but I don't need identity. And then we have primitive types, which are going one step further, which are saying, I don't want identity, and I also don't want references. So I get rid of both of these and get the benefits associated with not having them. Then we have universal generics and specialized generics, and I'm going to talk a little bit about all four of these. So let's start with value types. A value type is like a regular class, but you put the new keyword value in front of it. Well, it's not really a keyword. So if you have variables called value, never mind, they can still be called value. So technically, value is not really a keyword. In that context, it has a keyword role, though. And now, rational number it's mostly a regular class. You can do all kinds of things. You can implement interfaces, you can have methods, you have fields, you have constructors, all the good stuff. But there's some limitations. The class and the fields are implicitly final, and superclasses are very limited. But that's all. That's all the limitations you have there. But they do not have identity. So that means some runtime operations will fail. So you cannot synchronize on an object that does not have identity. So that would fail, for example. And if you do an identity check with the two equal signs, again, it doesn't have identity. So it needs to instead compare by the state of the fields. But benefits you get from that is due to the lack of identity, you cannot mutate such a value, so it's guaranteed to be mutable, and it's even more guaranteed than regular final fields, because these ones will probably be also protected from reflection. You can more clearly express what you want to do. Like consider, for example, domain-driven design, where the concept of a value actually has a meaning, right? And you want to produce those values, but in Java, if you don't use any extra tools, what you're creating is a long class that at the top you write, this is a value in my domain model. And this actually allows you to express that much more clearly. And you're going to get more optimizations from the JVM because it doesn't need to track identity. So that means, for example, it can just destroy and recreate an object whenever it wants, because it doesn't need to track what's the value of the synchronization flag. But it's still a reference. A value type is still a reference. That means you can still use null, and you still get protection from tearing. Once again, I'm going to skip that. Now, the interesting thing here is that many, many libraries, including the JDK, contain types that want to be values. So, for example, optional and local datetime within the JDK. And that is a quote about from the JDK, so we, the OpenJDK contributors, plan to migrate many value-based classes in the JDK to value classes. So stuff like optional, like local datetime. All of those things will become, hopefully, in the future when this works, value types. And now I said earlier that there are certain limitations on value types, like you cannot lock on them. Wouldn't that be an incompatible change? Now, if you're wondering that, you have not read the Java doc very closely. Because optional, local datetime, and all of these other classes, they have a sentence in the Java doc, usually towards the end, that says, this is a value-based class. So certain restrictions apply. And if you click the link to value-based class, you end up in a different site in the Java doc that explains a bunch of things that you should not do with value-based classes. Because when the optional and local datetime were introduced in Java 8, Brian Gotts already had a pretty good idea of what these limitations would be. So smartly, they put into the Java doc that the things that you can now will probably not be able to do with value types, that you should not do them in the first place with those old classes. So if you've never heard about this, I really recommend read up on value-based classes and then go check your code, make sure that, for example, you don't lock on an optional instance, which is not recommendable anyway because it's a really weird pattern. But you might be doing it anyway, so make sure to check that. Let's talk about primitive types next. So primitive, once again, you just put primitive there instead of value this time. And these code almost like a value class. So the same limitations apply. Plus, on top of that, you cannot reference your own type. So you cannot have a complex number as a primitive class that then references as a field another complex number. And the reason for that is that you want to embed this, right? You want to have an array of complex numbers should really be an array of rational, irrational. That should be an array of two long values back to back to back, instead of an array of pointers. And that means you need to know how long one of these instances is. Is it 2 long fields? Is it 5 long fields? If it references itself, then the length is unknown. And also, because it doesn't have references, you can't use null, actually. So the default value is all fields set to their defaults, and not null. Without a reference, it can't be null, right? Like that's the whole thing. What null is, it's the empty reference. And since this doesn't have a reference, it can't be null. That would also mean that a self-referencing primitive class would be like infinitely large, because you could never put a stop to it, where you say like, nope, this one doesn't have a next field. There's a way around it that we're probably going to skip as well, though. But the interesting thing here is you're giving up null, you're giving up the protection from tearing, but what you're getting is performance, hopefully, on the level of today's primitives. So that means that we'll be able to create primitive classes that basically behave from a performance point of view like primitives, but we can write our own code like that, we can add methods to that, and we can create, for example, the number types or the data structures that we need in a way that still allows them to be fairly optimal. And that's great, because everybody, for example, does maybe like high-performance programming, like gaming, for example, or other stuff where, let's say you have an array of points. And so the code you want to write is I want to have an array, and each value in that array is a point. But you know that the x, y coordinates are not actually in the array. Again, you have, each point is a pointer somewhere else in memory, and that's not great for coding. It creates garbage that you have to collect later. It gives you all these cache misses. So you end up with one array of x coordinates and one array of y coordinates, which isn't great. Like, it's not the code that we want to write. And Project Valhalla, gives us an option to write the code we want to write with the good performance that we want to have. Okay. Now there's something to be talked about here about boxes. Just like you have int and a box around int, which is called integer. So that's the thing, right, that we use occasionally. We also maybe want to do the same thing for primitive types that we create our own. I'm going to skip that, as I said, in the interest of time, but the slides are here. So if you want to look into that, I can recommend to check that out. Okay, so now we have value types and primitive types. They behave somewhat similar to today's primitives. Now the issue is that you cannot use primitives with generics, which is, it hurts sometimes, but it's not that bad because generics usually operate on like, domain objects or like more general objects, but they usually work on types that have like a more meaning or more complexity than just an int. So yes, it would be nice to have an array list of int, but we kind of can get away without because an int is not a very important domain concept in most of our code. But the issue is that once we all start creating value types and primitive types, once we all start to put code that used to be a regular class that works with generics into one of these new kind of types, and then they do not work with generics, that would be horrible. That would give you immediately the decision, okay, I have this new way to express my code and I get performance for it, but as soon as generics enter the game, you have to pick again. And that would be a non-starter. And for that reason, universal generics, or rather universal is the word I should highlight, will allow us to use primitives and primitive types and value types with generics. So that would mean we can write a list of long as a new array list. Now what that does not give us yet is that this array list is actually backed by a long array. It just allows this to express this in the language. That is actually not too complicated of a change. Java could have done this for forever, but it would still have to box. So you have an array list of int. Java could do that very easily. It would still be backed by an integer array, and that's not the great part. So that's why the feature is not there. With universal generics, you will be able to express this, but it needs specialized generics to really pull off the magic. And this is where I think at least 3 of those 6 PhD theses are probably buried in this part, which is, if we want to write array list of int, we don't want it backed by an object array. We want it to be backed by an int array. And when specialized generics come around, that will be the case. If, when, well. I really hope that it does that in the coming years. And then we can have generics over primitives without having the boxes that we have at the moment, which erases one of the most prevalent gripes that people have with generics, and also allows them to work much, much better with these new kinds of types that we're introducing. Okay, so overall, the idea behind value and primitive types and universal and specialized generics is to give us fewer trade-offs between design and performance. What I mentioned before, namely, you want to write the point class, but you don't get the performance, so you have to write code that is worse than the code that you actually want to write. And the issue with that specifically is that we as developers tend to think about performance too early, and we tend to think like maybe this is important and maybe I need to optimize without like proper benchmarking actually showing that it's necessary. But it's still not good to even have the situation in some cases where you like have to decide between these two polar opposites. So Valhalla wants to dramatically reduce the number of these trade-offs by giving us a tool that sits in the middle, which allows us to express what we want to express and get the good performance out of it. No more manual specializations. So there's stream, but there's also double stream and long stream and in stream. There's no float stream. I always made the joke that probably because the person who had to write all of these stream specializations was like, nope, not going to do that. You have to fire me. And I'm like, well, okay, like you can keep working. We're not going to have a float stream. Because this is a lot of work. Like the stream API is complicated considerably by the fact that you want to have a float stream or double stream that operates on the primitives instead of the boxed floats and doubles. Wait, don't have a float stream. On the boxed integers and longs. And this kind of stuff just goes away. Ideally, generics over primitives just work that way, and we don't need that anymore. That also means like the toInt function and the long binary operator, and all of that also goes out the window. The types will remain there, but they can be deprecated, and we don't need to use them anymore. We want to get better performance out of this. Within the JDK, within the libraries we use, there will be places where value and primitive types can be used. And so we'll get just better performance based on our dependencies, creating more performant code, and then we can do that in our own code as well. We can express the design that we want to express, like a value is much clearer what it does than if you write a regular class and then use the same semantics. And I think, and that's more like the last one, it's more my personal conjecture, it will help us to write more robust APIs. I think one big issue in larger systems that are split into several subsystems is shared mutable state. Is 2 subsystems knowing the same user, and then one of them setting the new username, but the other system not noticing that kind of stuff. And if we communicate more with value types and primitive types, which are immutable, then that means there's less chance of sharing mutable state, and that should make our code hopefully more robust. And overall, Java becomes more expressive and performant. Now, the timeline, again, is guesswork. This is very vague. Of all the timelines that I give you, this is the guessiest of all. So there are JEP drafts and JEPs for most of these features at this point, but they have been there for a while. You can see by the numbers 401, that's like, I think, Java 17, Java 18 timeframe. So they've been around for a while. I really hope that we'll see something next year. Like, this is probably too optimistic at this point, but I really hope that we see value classes preview very soon, and then the other two kind of belong together. It's really hard to imagine that you get the other ones not very close to one another. But specialized generics, I think that's the big one. And it has to follow soon-ish, but I think it will take some time after that. But I actually don't know. Maybe, maybe Brian Getz is preparing the JEPs for that now. Maybe he's doing the pull requests right now so to merge this into Java 20. I don't have that insight, but from the publicly visible information, it still takes a while, I would guess. There are deeper dives on this as well, of course. I can highly recommend the state of Valhalla documents. These are just great. The first two specifically are, I want to say easy to read, but if you're an experienced Java developer, they're easy to read. If you're not, you still have to think through them a bit, but they're understandable. The JVM model is much more low level. I cannot generally recommend to go into that. I did not understand it. But the other two are really great. They really introduce the problem and the solutions that were considered and what the current solution looks like. And I also linked some videos here. That's it for Valhalla. Let's talk a little bit about unrelated stuff. None of the 4 projects. Because there's so much more going on. So whenever new Java versions come out, it's not only these big projects that do their stuff, right? So for example, we have a bunch of new APIs that get new additions or that get introduced. So for example, one thing I want to point out, maybe let's pick the random generator API. That's a pretty cool one. So if you're dealing with any kind of randomness, at the moment you're bound to the classes like random and thread local random and splittable random, and there's a 4th one that I forgot right now. And they're not great. They have some shortcomings. The implementation isn't great either. The algorithms that are implemented there can technically not change because they're part of the specification, or at least somewhat. And this new API gives you much more influence on what kind of algorithm you want to use for pseudo-random number generation. It has a unified API that is easier to use. You now have an interface that you can use, the random generator interface, and then you can exchange the implementation, for example, through dependency injection. Just an all-around better API, and that happens like all the time. Usability improvements, like we now have UTF-8 by default. This very presentation is a website. I have to be careful not to click a link. And it's running in Chrome right now, and I need to launch a server for that. You can see it's on localhost, and that server is the JWeb server. Since JDK 18, there's a simple web server being shipped with the JDK. You just go JWeb server on your command line, and boom, you got a running server for for testing or for prototyping purposes. There's a bunch of stuff going on in the tooling region, like Java Flight Recorder sees constant improvement. The recent feature is scrubbing, which you can use to eliminate potentially privacy-relevant information from the JFR files. You have code snippets in Javadoc, which is great. You can now use that to have actual source files with Java code that you compile, and then pull examples from that into your Javadoc. You're all writing Javadoc, right? Yes? No? Well, I hope so. Somebody raised their hand. One person writing. 2. Who writes Javadoc? Yes. Amazing. Okay, so if you put examples into your Javadoc, that's just text, right? And those don't compile, you will find out when the users complain. This way, you can have actual source files that are compiled, even tested if you want to go the extra mile, and pull snippets of that into your Javadoc. Just great stuff. Performance improvements are constant. I can't even go in there. There's so much going on there. Java performance improves from release to release. Garbage collection specifically sees a bunch of changes there. Likewise with security, I can only recommend Sean Mullen's blog. Sean Mullen is in charge of OpenJDK security, and he writes like clockwork, 1 blog post every 6 months for the new Java release, where he goes through all the things that are new, like new networks standards, for example, that are implemented, like TLS and new pseudo-random number generator algorithms, that stuff, security bugs. There's a lot of good stuff in there. But we're not only adding stuff, things are also getting kicked out. Very rarely, nobody's taking the shotgun to the OpenJDK codebase and just randomly killing stuff. But there are certain things in there that are a huge drag on the development of OpenJDK and that don't provide the value that is needed to make that worth it. So a bunch of things have already been removed. And from the top 3, I think finalization and security manager will still take a while, probably, is my guess, before they're actually removed. But I wouldn't bet on the applet API and bias locking a whole lot. So with stuff being removed and all these new features, what can you do to make migrations easier? There's a bunch of tips on this slide which all read very easily. For example, just keep dependencies and tools up to date. There you go. Single line on a slide should be easy, right? So I know that these tips are not necessarily easy to fulfill, but I still want to encourage you to do that. Make sure that you stick to the supported APIs, to standardized behavior, to well-maintained projects that actually update with recent Java versions as they come out. And also stay ahead of what's happening. I already showed you the slides with things that are deprecated for removal. If you use JDepreScan, you can already know that. That's a command line tool that scans bytecode, for example, your bytecode and also your dependencies bytecode, and then spits out a handy list of you using these deprecated library APIs, and these are marked for removal. So you can see now, let's say you're on Java 11, so that you can see now what is deprecated in 19, so you don't keep piling code on something that's going away. Again, this is not just going to be random removals, but there are certain things in there that are getting removed and that you should be aware of. And if you do that, you can much earlier adopt these new features. Okay, talking about adoption, I want to ask you all a question. So who has a Java Java app in production right now? I assume that's almost all of you. No? Okay, almost. So who of those, I want to ask about the newest version that you have in production right now. So who of you has the newest version that you have in production is on 7 or lower? ABN AMRO? No? Sorry, it's a bank joke. Okay, so 8. Who's on 8? It's a bunch of people, but way fewer than last year when I started asking this question. Okay, there was maybe like, I don't know, 10, 15%. Who's on 11? Wow, that's like at least double that number. Now, who's on 17 as the newest? That's the same people, even more, I think. Not the same people, but the same number of people, a little bit more even. That's great. So, oh yeah, basically I want to show you this. So, Java 11 is slowly but resolutely overtaking Java 8. I think we can put a check mark behind that. I think that's done, at least at conferences. Adoption of Java 17 from 11 looks good. I want to ask another question to people on 11. Of the people who are on 11, who think they will be on 17 within the next 6 months, say? That's a chunk of people. That's what we've seen a lot. Because like the jump from 8 to 11 was not always easy, but from 11 to 17 was much better. And so I think you should really look into that. And I think it will go quite well. Who's using the latest? Who's running on 19 right now? Okay, not many, but a few. That's good. So I want to encourage you as well to look into that. Because if you've gone from 11 to 17, you might have noticed that even though you just skipped 6 Java versions, it wasn't that much of a hassle, was it? And now, so that could make it easier to then go with each release, which gives you, productivity increasing language features, better API, a safer runtime. Well, yeah, a safer runtime on 17. Of course, you also get security updates. So scratch the safer, but more performant runtime on each individual with each individual release. Okay, with all of that done, I have a few minutes left to talk about Project Loom, but I'm not going to go very far into that. I'm going to tell you why in a second. So, the Project Loom deals with JVM features and APIs for supporting easy-to-use, high-throughput, lightweight concurrency. That's one thing. And new programming models. That's a different thing. We're going to see that in a second. So a bunch of links. Again, this was launched just in January 2018. This is just 4.5 years old, and Ron Pressler has done miracle work by already previewing these features now in Java 19. So the motivation behind this is, if you think about a hypothetical HTTP request that does something very similar in your CRUD app, you interpret the request, right? You pass out some JSON and figure out what you want to do. And you go to the database, and then you sit there waiting for the database to reply. The database is busy, but you aren't. You get the response back. Fiddle away the result set and put everything into an HTTP response and send it over the wire. If you think about the resource utilization of the runtime of the Java runtime, then it's great for 1 and 3, and for 2, you're just sitting there waiting. And now the question is, how would you implement that? And there are 2 big approaches. The first one is synchronous. You have a unit of concurrency in your app, and that is you have to handle concurrent requests. And you have a unit of concurrency in the JVM, which is threads. And the obvious approach is to just pair these and say, well, the unit of concurrency in my domain is the same thing as the unit of concurrency in my technology. So 1 thread per request. And that's great. It's simple to write, simple to debug, simple to profile. A thread blocks on certain calls. And that's kind of the issue, right? Because the threads that you're using here are threads that are managed by the operating system. And they're expensive-ish. You can have thousands, maybe tens of thousands, maybe even hundreds of thousands, but it ends there. So you can't have an unlimited amount. So this is a resource that you have to be somewhat careful with. And for that reason, asynchronous programming came up, where people had this revolutionary idea of, what, if platform threads are expensive, maybe we should only use them when we actually need them, only for computation. And so what you end up with is non-blocking APIs that use futures or just the whole reactive stream stack. That is a little bit harder to write, although I understand that some people really enjoy that because they think it gives them a clearer approach to several things that are going on there, like exponential backoff or something. But it definitely becomes more challenging to debug and to profile, and it's a higher burden, higher threshold for people to enter your project to understand. It's also incompatible with synchronous code. If one of the libraries you're using doesn't know about this and just starts blocking threads, that's not great. But it shares platform threads, and that gives you much better resource utilization but higher throughput. And that gives you a conflict between simplicity and throughput. And these kinds of conflicts, I mentioned that before, are very common in programming in general, and these projects really want to tackle that. The conflict for Panama was safety in foreign memory versus performance in foreign memory, for example. The conflict in Valhalla was well-designed code versus high-performance code. And the conflict here is a simple code versus high-throughput code. And that's a bad situation to be in always. And so these projects try to resolve these conflicts. In this case, by giving us virtual threads. A virtual thread is like a regular thread. This strange font here, you have seen it before on the slides. That means that thread is a name of a class. So a virtual thread is an instance of the class thread, of a hidden subclass, but still. A super low memory footprint of bytes in the low range of kilobytes, a small switching cost, and it's handled by the Java runtime. That's very important because the Java runtime has to have much fewer boundaries between different threads than, for example, the operating system has to put up. And it requires no operating system thread when waiting. That's the important part. So when a virtual thread waits, the actual expensive operating system threads, of which you cannot have unlimited numbers, they can still be busy and do something else. So the way you manage this is that you run basically a thread pool of, we call those carrier threads, and then you put a virtual thread onto a carrier thread, and they do their work. And then when a virtual thread blocks, what instead happens is it yields the carrier thread. So the virtual thread thinks, I'm blocked now. The carrier thread gets detached, goes back into the pool, can do something else. And then when the virtual thread is done, when the operation is done that blocked the virtual thread, they get recombined on a different carrier thread potentially and continue. So if we go over the example that I showed you earlier, then we see that first we interpret the request, and that's going to happen by the runtime submitting a task to the carrier thread pool, and then it's going to be busy with that. But when two blocks, the virtual thread sits there, and if you look at the stack trace of the virtual thread, it sits in a method that looks, it's blocked, right? The IDE will tell you it's blocked, everything looks blocked. But the carrier thread is back in its pool, handling other requests like this. And when two unblocks, the runtime resubmits the task to the thread pool, and then it continues. And from the virtual thread's point of view, you do not know that there's a carrier thread. You cannot see the carrier thread's ID, you cannot access its state. These are entirely decoupled, which is necessary so that there's no leaking. So the virtual thread just thinks it's blocking and everything is going on as normal, but you're basically having this thread pool underneath. And that means that the virtual threads are debuggable just like regular threads would be. You can write blocking code, and you don't have to mind that the virtual thread blocks because it does not block an expensive resource. A virtual thread is not so much a resource at all, it's more like a domain object. It's like, I want to do 2 million things at the same time, so I'm going to create 2 million virtual threads. Just like when you want to handle 100,000 users, you're going to create 100,000 user objects, right? So that's very similar. Okay, so there's more on Loom later. There's a talk by Marcel Thon, which is called Threading the Needle, Multi-Threading with Project Loom, that takes place at 10 to 4 in room 5. It's only 16 minutes, not 15, not 17. It's 16 minutes long. And if you want to know more about Loom, I can recommend to go there. I can also recommend to look at the Java YouTube channel, where my colleague Jose Pomar made a bunch of videos. And you can learn more about virtual threads, but also about the second part that I did not mention now, which is called structure concurrency, which uses the ubiquity and the ease of creation and the limitless of virtual threads to give you a new approach to write concurrent code. Okay, so with that, I want to say I'm done. The slides are online, as I mentioned. I wrote a book about the module system, but I think it's very important, not the book, the module system. Check that out if you're interested. You can follow me on all the platforms. I'm NipaFX everywhere, on Twitter, on GitHub, on YouTube, wherever. But maybe more importantly, I work for the, as I said, for the Oracle JDK team, and we do a bunch of interesting stuff on insight.java. Is this kind of content, like what's coming, is interesting to you? You definitely have to check out insight.java. We even have an RSS feed for, RSS aficionados like myself, where you can see different things happening on the mailing list, the important stuff that happens on the mailing list. A new JEP is proposed, a new project is launched, a new milestone is reached. All that stuff shows up there. I can highly recommend to check that out. If you want something that more like regular developer-facing, dev.java gives you a bunch of introductions to the module system, for example. I wrote that. To the Stream API, Jose wrote that. So there's a bunch of good stuff there. Follow us on Java at YouTube. And with that, I want to say thank you very much for your attention.